The future of naval warfare is changing faster than ever, and the U.S. Navy FY2026 naval vessel program is shaping up to be one of the most ambitious modernization efforts in modern maritime history. This next-generation destroyer concept is designed to combine stealth, firepower, artificial intelligence, advanced radar systems, and unmatched versatility into a single warship capable of dominating the seas for decades to come. At first glance, the vessel immediately stands out with its aggressive futuristic profile. Every angle of the hull appears carefully sculpted to reduce radar visibility, giving the ship a stealthier signature compared to older destroyers. Instead of large exposed surfaces and traditional vertical structures, the design uses smooth lines, enclosed sensor arrays, and integrated systems that help the vessel blend into the background of the ocean when viewed by enemy radar. It almost looks like something out of a science fiction movie, yet much of the technology behind it is very real and actively being developed for the Navy's future fleet. One of the biggest highlights of the FY2026 destroyer is its next-generation integrated combat system. Unlike older warships where different systems operated somewhat independently, this vessel acts more like a giant floating combat computer. Sensors, weapons, drones, communications, and navigation systems are all linked together through artificial intelligence-driven software capable of processing massive amounts of battlefield information in real time. This allows the crew to react faster to incoming threats, coordinate attacks more effectively, and reduce human error during high-pressure combat situations. The ship is expected to use advanced machine learning systems to identify enemy aircraft, missiles, submarines, and surface ships almost instantly. In simple terms, the destroyer can think faster than previous generations of naval vessels, giving it a huge advantage during modern warfare where seconds can decide survival. The radar system aboard this vessel is another major leap forward. The destroyer is believed to feature an upgraded version of the spy radar family, capable of tracking hundreds of targets simultaneously across enormous distances. This includes enemy stealth aircraft, hypersonic missiles, drones, and ballistic missile threats. The radar arrays are integrated directly into the ship's superstructure rather than mounted externally, creating a cleaner appearance while improving stealth characteristics. The system works alongside advanced electronic warfare equipment designed to jam enemy sensors, confuse missile guidance systems, and protect the ship from coordinated attacks. In today's battlefield, electronic warfare can be just as important as traditional weapons, and the FY2026 destroyer appears designed with that reality in mind. When it comes to firepower, this vessel is expected to carry some of the most advanced weapons ever installed on a destroyer. Vertical launch systems positioned throughout the deck can deploy a wide range of missiles for different combat scenarios. Long-range surface-to-air missiles provide protection against aircraft and incoming missiles, while anti-ship missiles give the vessel the ability to strike enemy warships at extreme distances. Land attack cruise missiles allow the destroyer to support ground operations by targeting enemy infrastructure, command centers, and military installations far inland. Some reports also suggest compatibility with future hypersonic weapons capable of traveling at several times the speed of sound. These missiles would dramatically reduce enemy reaction times and increase the Navy's ability to penetrate heavily defended areas. Another fascinating aspect of the FY2026 destroyer is the growing role of directed energy weapons. Laser weapon systems are becoming increasingly important in modern naval warfare because they can engage drones, small boats, and incoming missiles at a fraction of the cost of traditional missile interceptors. Instead of spending millions of dollars per missile shot, lasers use concentrated energy beams powered by the ship's electrical systems. The FY2026 vessel is expected to have a much more powerful integrated energy network compared to previous destroyers, allowing it to support high-energy laser systems and possibly even electromagnetic railgun technologies in the future. This massive electrical capacity is one reason why the ship is often described as a power platform, rather than just a conventional destroyer. Power generation itself is one of the most impressive engineering achievements of the vessel. The destroyer is rumored to use an integrated electric propulsion system, where powerful generators produce electricity not only for propulsion but also for weapons, sensors, and onboard systems. This setup increases efficiency, reduces mechanical complexity, and creates a quieter acoustic signature underwater. Quiet operation is incredibly important because submarines rely heavily on sound detection to locate enemy ships. By reducing noise levels, the destroyer becomes harder to track beneath the waves, improving survivability in contested waters. The propulsion system also allows smoother acceleration and potentially greater fuel efficiency during long deployments across the Pacific or Atlantic Oceans. Despite all its advanced technology, the ship still focuses heavily on survivability. Modern naval warfare involves threats from every direction including missiles, submarines, drones, cyberattacks, and electronic warfare systems. The FY2026 destroyer is designed with layered defenses to counter all of these dangers simultaneously. Its stealth shape reduces detection chances, electronic warfare systems disrupt enemy targeting, missile defense systems intercept incoming attacks, and close-in weapon systems provide last-ditch protection if threats get too close. Advanced damage control systems using automation and smart sensors can rapidly identify fires, flooding, or structural damage, helping crews respond more effectively during combat. In many ways, this vessel is built not only to fight but also to survive in some of the most dangerous combat environments imaginable. The crew experience aboard the destroyer is also expected to improve significantly compared to older warships. Automation reduces the number of sailors required to operate the ship, which lowers operating costs and frees up more internal space for living areas, mission equipment, and future upgrades. Advanced touchscreen interfaces, digital command centers, and AI-assisted monitoring systems simplify daily operations and reduce workload stress for crew members. Habitability is becoming increasingly important because modern deployments can last for months at sea. Better sleeping quarters, improved climate control, quieter machinery, and upgraded recreational areas all contribute to maintaining crew morale and operational readiness during extended missions. Another major advantage of the FY2026 destroyer is its flexibility. Modern naval missions are incredibly diverse. One day a destroyer may escort aircraft carriers through hostile waters, and the next day it could conduct missile defense operations, launch strikes against enemy positions, track submarines, or deliver humanitarian aid after natural disasters. The vessel's modular design philosophy allows the Navy to adapt systems and mission packages depending on operational requirements. This flexibility ensures the ship remains useful even as future threats evolve over the next several decades. Drone integration is another game-changing feature expected on the vessel. The destroyer will likely operate alongside unmanned aerial vehicles, unmanned surface vessels, and possibly underwater drones. These systems dramatically expand the ship's reconnaissance and combat capabilities without placing additional sailors in danger. Aerial drones can scout enemy positions far beyond the horizon, while underwater drones can search for mines or track submarines. Some unmanned systems may even carry weapons of their own, effectively extending the destroyer's combat reach across vast areas of the ocean.